First, let's talk about what creatine is. It is a compound made by several amino acids, specifically glycine, arginine, and methionine. So your body takes these three amino acids and through several biochemical reactions forms creatine. Now, it's produced in the body predominantly by your liver and your kidneys, and also pancreas in smaller amounts. It can be made in the testes as well in men, and so, but minute amounts. The vast majority of it is liver and kidney, and then it's stored in your muscles. It's a major component of how we make energy, how we make something called ATP, adenosine triphosphate. So 95% of total body creatine is stored in our skeletal muscles. The rest is in your brain, your heart, and in other tissues that have high energy demands. Now, creatine, most of you have heard of it as a supplement, and it's making its rounds right now through, through social media as something that a lot of people are talking about and recommending for a number of different reasons. Hence why I'm putting together this crash course for you, because I want you to have the solid scientific foundation and basis for whether or not you need to supplement and what creatine may be helpful for you for. So, key roles for creatine. It has several different functions. Its primary role, though, is in energy production. It helps to regenerate ATP, which is where our body gets its energy from. This is, you've heard of that powerhouse of the cell, the mitochondria. This is where our ATP is generated, and creatine is used to make that process more efficient and long-lasting. We know that creatine fuels muscle growth. As a matter of fact, I said this is one of my favorite supplements. This is something that I personally use on a regular basis. I use about 5 grams of creatine in water every day after my workout. And this is especially important, in my opinion, for those of you who are above 40. As you get older, it's more difficult, or can become more difficult, to maintain muscle when you train, and if you're exercising, and creatine can offer vast benefits for that. So, fuels muscle growth. And when I say that, ladies, don't be scared to take it. It doesn't fuel muscle growth and make you Herculean. It just helps you build nice, lean muscle. Enhances protein synthesis and cellular hydration. So it actually pulls water into the cells and makes them fuller and more hydrated. And so it also helps with faster growth. So if you are on a timeline and you're trying to build muscle quicker, it's very effective that way. But it also helps people recover. So if you're one of those, you've worked out in the past, and the muscle soreness, what they call the DOMS, the delayed onset muscle soreness, is so severe for you that you work your legs out and you can't walk for a couple of days, and you're really leery about wanting to do exercise because of that soreness, creatine aids in that recovery. There's actually antioxidant benefits that creatine provides to your muscle that helps reduce the damage and increase the healing time. We know creatine can protect the brain. This is one of the areas where we store a lot of creatine. Shields against energy deficits and as well oxidative stress. Remember, oxidative stress is one of the root causes of neurological damage in the brain, and Alzheimer's and dementia and other neurological conditions. We know from research that it actually sharpens brain function. There are a number of studies showing that it improves energy for better focus, reduce fatigue. There's also research I'll show you in a moment on anxiety and other mental conditions where creatine has been found helpful in human studies. We also know it supports metabolic health by regulating blood sugar. It aids in glucose metabolism. One of the things that creatine has been shown to do, and this is actually in humans, is it improves the glucose utilization of your cells. So if we look at a cell, that's your DNA. Excuse my drawing. I'm not the greatest drawer in the world, but in the surface of your cells, in the membrane of your cells, you have these little doorways called GLUT doors. And so these are doors that open and allow for the glucose to come from your bloodstream. So if this is your blood vessel and this is glucose, glucose comes through this door and then it runs through several processes in your cell, and this is how we make ATP, right, as we convert that glucose into ATP eventually. But these GLUT doors on the surface of your cell, creatine makes those doors work better, and it makes the genetics of production of those doors more readily, and so it actually enhances GLUT door production to receive and to process glucose better. Okay, let's talk about some of the myths and misconceptions around creatine, because a lot of people, I've seen this a lot, my practice, I have young men that are trying to build muscle, and they want to take creatine, but mom is super nervous about it because they've heard maybe from another doctor that creatine is dangerous and causes kidney damage. By the way, that's not true. So let's talk about some of the misconceptions around creatine, and I'll go through this list. This was actually, you can see here, this was a great article published by many experts in the Journal of the International Society of Sports Nutrition on creatine. So you can see common questions and misconceptions about creatine supplementation. What does the evidence, scientifically evidence, really show? And so they go through all these different points. I've highlighted the things that I think are important. So number one, I've heard this question so many times, but creatine is not an anabolic steroid. It's not a steroid. It's not an illegal drug. It's not a prescription drug. Creatine is a substance your body naturally makes from amino acids, which you can eat from foods as well. So it's not a steroid. Number two here, number three on the list here, creatine supplementation, when ingested at recommended dosages, does not result in kidney damage. Does not result in kidney damage and or renal dysfunction in healthy individuals. The available evidence does not support a link between creatine supplementation and hair loss. It's another one I get asked. You have to understand that steroids, testosterone, there's a lot of people confuse creatine and testosterone. I don't know why, but they do. Testosterone causes hair loss. It causes kidney damage. It causes liver damage, among other things. Testosterone, especially in those larger doses where those bodybuilders are really trying to Hulk out. But creatine doesn't do any of those things. It does not cause dehydration or muscle cramping. It is safe and potentially beneficial for children and adolescents. So if you've got a child, and I have seen this too, I've had a number of patients come to see me with muscular dystrophy and other genetic disorders of childhood affecting their muscles. And we use creatine monohydrate therapeutically in kids. So it's not dangerous for kids. If you've got a child and you're looking to increase sports or exercise performance, and you're concerned about the safety of creatine, you don't need to be if it's being appropriately dosed. What is that dosing? In a kid, it's anywhere from 2 to 5 grams a day. And creatine generally comes in a granulated white crystal powder, and you mix it with water. You can put it in a juice or a smoothie and take it directly after a workout, but very, very safe to take. No danger for kids or adolescents, no danger either for adults. Creatine supplementation does not increase your fat. It increases your lean muscle, and it increases your body's ability to make energy. So it does not increase your fat mass. Smaller daily dosages of creatine supplementation, 3 to 5 grams, or they say 0.1 grams per kilogram of body mass are effective. Therefore, a creatine loading phase is not required. We'll talk about that when we talk about creatine supplementation. We're going to dive into how to supplement with it shortly. Creatine supplementation in resistance training produces the vast majority of musculoskeletal performance benefits in older adults. I want to call something out here. You notice this is creatine supplementation and resistance training, meaning both. If you just take creatine but you don't do the resistance training, you'll still have some benefits of creatine in terms of energetic production. But when you add the two, when you combine resistance training with creatine, you get a synergism that trumps just taking creatine alone, or that trumps just resistance training by itself. It's beneficial for a variety of athletic and sporting activities, not just for weightlifting. Creatine supplementation provides a variety of benefits for females across their lifespan. As a matter of fact, it's interesting if you look at the female cycle, as estrogen goes up in the female cycle, so too does the body's production, internal production of creatine. So if this graph represents creatine and this represents estrogen, it's estrogen being an important hormone for women. It's important for growth and healing and repair, but creatine kind of follows a curve with estrogen throughout the woman's cycle. This is one of the reasons why when we see that estrogen drop, I think we see some of that energy level in females drop too. Remember, creatine, a very important source of energy generation. So other forms of creatine are not superior to creatine monohydrate. So there's every type of salesman in the world out there trying to tell you, take this creatine or that one, this micronized version, or take it with this product or with these other things. But creatine, pure creatine crystallized monohydrate is where it's at. And all the research shows that to be the case. That's what I personally take, is creatine monohydrate. I don't fall for all that other marketing stuff that's out there. Okay, let's talk about how creatine is produced in your body. Your body makes creatine too. So in your kidneys, so this diagram kind of generally represented, I'm going to call some things out here. So in your kidney, your kidneys will take the amino acid arginine, ARG, that's arginine, and the amino acid glycine, and run it through an enzyme called AGAT. This enzyme will then create a substance from those two amino acids. It'll create a substance called guanidinoacetic acid, or GAA, which is what that is right there. So in order for this enzyme to work, so this enzyme I've got highlighted here in red, this AGAT enzyme, again, it takes arginine and it takes glycine, and it runs them through a chemical reaction to generate pre-creatine substance. This enzyme is reduced, its functionality is reduced when we have vitamin E deficiency. So it's important to know, if you're trying to make your own creatine and your vitamin E is low, you won't make it as effectively. It's also, this enzyme is inhibited or reduced in people that have low protein. So what have we been seeing push a lot in the media in the last several years? We've been seeing kind of low protein diets, animal-free, plant-based, diets being pushed. Now, when you're done watching this show today, you're going to know why that's not the greatest idea in the world, and why we need to eat foods that contain creatine. We need to eat enough protein to drive this enzyme so that we can make our own creatine as well. We also know that fasting causes a reduction in this enzyme that helps us make creatine. So now, I'm a fan of fasting. I think there's definitely some benefits to fasting, but I think, just like with many things, people take a good thing, push it too far, and then, what's the old saying, more is better, right? When you go to the buffet, more food is better. No, not necessarily. You push fasting too far, too long, you can have some profound impacts on your body's ability to generate creatine, which is going to affect your energy production. Now, this all happens in the kidney. So what else might affect this is somebody who has pre-existing kidney disease. So if you've got, stage 1, 2, 3, 4 kidney dysfunction, your ability to make creatine is going to be diminished. There's actually some research where doctors are wanting to put creatine in the dialysate of people who are on dialysis. So these people with kidney disease, diabetes, who are going in for dialysis, they're doctors that want to add creatine into that dialysate back into the body to help with energy production. So kidney disease can reduce your body's ability to make its own creatine. So can liver disease. Because if we look up here, this is your liver. So we've got this enzyme GAA, or guanidinoacetic acid, that then is converted in the liver. You got GAA right here, and then you have this process where there's an enzyme that helps. This enzyme, by the way, is a methyl enzyme. So if you ever heard of methylation, methylation is the process we use to convert GAA into creatine, CR. That's what creatine is, that's CR. So we take a methyl group and add it to this to this amino acid compound, and then now we have creatine. And so this product, because it's a methylation product, what does it require? Folate and vitamin B12. So if your folate is low or your vitamin B12 is low, it's also going to hinder your body's ability to make your own creatine. So now we've got 3 nutrients in the mix here. We've got folate, B12, vitamin E, actually 4 because we also have protein. So in order to make creatine, you need to eat enough protein to get the amino acids arginine, glycine, and then methionine. That's what that is. You need to make sure you're eating enough protein. You need to make sure you're getting enough vitamin E. You need to make sure you're getting enough folate and B12. Okay, and so if you have all those things in your liver will produce adequate quantities of creatine, and then that creatine, what did we say earlier, that about 95% of your creatine is stored in muscle tissue, and that's what this represents, is muscle. And so then once it's in your muscle, you go through there's another chemical process, this little enzyme here, CK, that stands for creatine kinase. CK for short, but it basically converts creatine into phosphocreatine, which is this substance right here. And it's the phosphocreatine that helps drive more ATP and, in essence, drive more energy. Now, a note, because I know maybe some of you have gone to the doctor and you've had some lab testing done and you've seen this term, creatinine. Creatinine is not creatine. This is typically it's a marker that doctors will measure in your urine or in your blood, and it helps to identify kidney function. It's not the same thing. Don't get confused. I get this all the time. People come to me, they bring me their creatinine tests and say, do I need to take creatine? It's not the same thing. So CK, creatine kinase, now this is another, you ever see this on a lab test? Doctors will sometimes use a creatine kinase lab test. It's a blood test to measure for a heart attack, heart damage. You can measure CK enzymes for muscle damage. You can also measure CK enzymes for brain damage. So there's what we call isoenzymes, CK isoenzymes. What are they? The isoenzymes are, there's CKMB, which is your heart. There's CKMM, which is your muscle. And then there's CKBB, which is your brain. So if you ever go to the doctor and they ran this CK test, maybe you had muscle aches, muscle pains, and they ran this CK test, that's what they're looking for. They're looking for elevations in this enzyme because it could be an indicator that you have damage to those 3 tissues. But CK by itself is the enzyme that includes all of these, the creatine kinase from your heart, from your muscle, from your brain. So you can ask your doctor to do an isoenzyme test, which breaks those 3 down so that you could know. So if your CK is high, maybe most of your CK is high because it's your muscle damage, or maybe it's coming from your brain. So you can isolate where the damage is coming from if you ask your doctor to run the isoenzymes. That's just a little side note on lab. So again, it's this CK, this creatine kinase enzyme that converts creatine into phosphocreatine, which is how we then subsequently get energy. Now, on another side note, there's something we've been talking about this, all year so far, which is mold. Mold, especially fumonisin and aflatoxin. These are mold toxins, sometimes referred to as mycotoxins. But these mold toxins, when we know from animal studies that these mold toxins will inhibit the function of the enzyme creatine kinase. This is one of the reasons why exposure to mold can cause fatigue, because when you block CK, when you block creatine kinase, you don't make as much energy. One of the side effects of that is definitely fatigue. So a lot of mold patients have a chronic fatigue diagnosis. They've been diagnosed with either chronic fatigue syndrome or something like ME, myalgic encephalitis, which is inflammation of the brain. Again, creatine kinase is rich in muscle, liver, and brain tissue. We'll also see mold toxins cause liver damage. And again, one of the reasons, one of the mechanisms of action is that it inhibits this enzyme, the CK enzyme, which is responsible for helping our bodies produce energy. And when your body can't make energy, things start to deteriorate and break down. So just an aside for those of you struggling with mold, helping you understand that mold connection a little bit better.